solving a system of linear inequalities. So if I was given two inequality equations here, so y is greater than 1/2 x minus 1, and y is less than or equal to negative 4x plus 3. Now the first thing here, we have inequalities. Second, we do want to solve as if we were solving for y equals mx plus b. We want to make sure y is by itself, and it is. So I would graph these just like I would graph one linear inequality. I would start at the b at negative 1, and then I would use my slope to get more additional points. So up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. I would look at the symbol. If it's greater than or less than, I'm only going to have a dashed line because the solution will not fall on this dashed line. But what happened there is where they would be equal. So I need to put the dashed line to represent where my solutions are going to not be on this line, but it'll be above or below. So here we have a greater than symbol, so it's going to be above. Now, if we're unsure where to shade, what you would do is grab a test point. And usually we test 0, 0. So if I was to plug a 0 in for y and a 0 in for x, I would get that 0 is greater than negative 1. And that is true. So what that means is that this point is in the shaded region. So when I shade here, I'm going to shade to include my test point. And this would be above the line. So any point in that shaded region will come out to a true statement when plugged in. Let's look at the second inequality. Y is less than or equal to negative 4x plus 3. So I'm going to start at 3, 1, 2, 3 on the b, on the y-axis. Then I'm going to go down 4 and left or right 1, or up 4, left 1. And I can continue doing that, down 4 here, right 1. Now this time, because it is or equal to, I will have a solid line, because there are solutions on this line where they are equal to. Now here I want to shade where it's less than, which generally rule of thumb will be below the line. But let's test our test point 0, 0. 0, less than or equal to negative 4 times 0 plus 3. 0, less than or equal to 3. Again, another true statement. So 0, 0 is in the shaded region. So I would have to shade where 0, 0 is included. Now where we see that shading on both is going to be my solution. So my solution is in this region, and that's what's going to happen. You're going to have a region as your solution. So there's an infinite amount of points here that would satisfy both of those linear inequalities. Let's take a look at another example, but this time let's make it where we're going to need to solve at least one of them for y. So if I was given the inequality, the linear inequality, negative 2y is less than or equal to x minus 2, and then also y greater than or equal to negative 1/2 x plus 4. Now the second one is solved for y, but the first one is not. So I would need to solve for y. So I need to divide every single term here by negative 2. But what happens when you multiply or divide by a negative in a linear inequality, my inequality is going to flip. So now I'm going to have y is greater than or equal to negative 1/2 x plus 1. Now I'm going to graph these two linear inequalities. And what we notice is they have the same slope. So yes, they are going to be parallel, but let's see what happens with my shading, because a couple things could happen when shading. Here I'm going to start at 1, the b, down 1, right 2, down 1, right 2, up 1, left 2. We do have 4 equals on both, so both of these are going to be, we're going to have our solid line. Now here is where it's greater than. So generally I would say I want to shade above. But let's test our point 0, 0. So if I put 0 in for y, greater than or equal to. Now if I put 0 in for x, that's going to cancel out 1. Is 0 greater than or equal to 1? No, that is false. So this test point is not in the shaded region. So I'm shading away from that test point. And again, greater than symbol, you would shade above. Let's look at the second inequality. I would start at that 4. 1, 2, 3, 4. And then I'm going to, again, have my slope down 1, right 2, down 1, right 2. Or up 1, left 2. And again, it's a solid line because it's or equal to. Here, we're also shading above. So again, if I put in my test point, 0 greater than or equal to, 0 cancels out that negative 1/2, 4. Another false statement. So I would shade above. So I look here. Although they're parallel lines, they do have a common shaded region. Right here, all in here, is going to be your solution set, which has an infinite amount of points. We could have also had a solution inside, in between, or if we were shading above the purple line, but below the blue line, then we would have a no solution. So it is possible to have a no solution, but that only happens, again, in parallel lines, where you're shading above and then below, and they do not have any intersecting shaded regions.